Okay, folks, we're back on page 2 here. So now we're going to talk about degrees, zeros, turning points, and behavior. So we're going to look at, we've got 6 examples here, kind of 3 at the top and then 3 in the middle, different kinds of polynomial functions, and we're going to look at some of the properties here. So the first one is a constant function. This is like y equals 2, which is a horizontal line. Notice that the domain is negative infinity to positive infinity. In this case, the degree is 0. And so it's kind of like having 2x raised to the 0 power. So the degree is 0. The number of zeros, we only cross the x-axis. In this case, we don't actually, because it's going to be parallel to the x-axis. So the number of zeros is 0. Now a linear function, this is like y equals mx plus b. So here's the example here. The degree is 1 because it's x to the first. Now the number of zeros, 1. We cross the x-axis in one place. For the quadratic, where your lead term is x squared, the degree is 2. The number of zeros, notice we have 2 of them. We hit the x-axis in 2 places, so 2 zeros. The number of turning points is 1. In this case, it's the minimum. We go to the minimum and then we turn. So it's a decreasing function till we get to the minimum. Then it's increasing. 1 turning point. As x approaches negative infinity, so as we move to the left, the function is going up. So the function is going to positive infinity. And as x approaches positive infinity, as your x's move to the right, the function is going up. So it's also positive infinity. So notice the end behavior in both cases, they're the same. So let's go to the cubic function. Cubic function is x to the third is your lead term. So the degree is 3. Notice the number of zeros is 1, 2, 3. The number of turning points, 1. Then we come down 2, we turn again. So we have 2 turning points. Now the end behavior, as x approaches negative infinity, the function is going down. So the y values approach negative infinity. As we move to the right, the function is going up. So as x approaches positive infinity, f of x approaches positive infinity. Now at this point, you might be noticing a couple patterns. Notice that the degree and the number of zeros are the same. 3, 3, 2, 2 for the quadratic. A quartic function is where the lead term is x to the fourth. 1, 2, 3, 4. Degree is 4. Number of zeros is also 4. Turning points. So we start by coming down, 1 turning point. Then we come up, 2, 3. Notice the turning points, the number of turning points is always 1 less than the degree. As x approaches negative infinity, the function is going up, so the function's approaching positive infinity. As x approaches positive infinity, as we move to the right, the function is also going up, positive infinity. And then the last one we'll do is where your lead term is x to the fifth. So that's degree is 5. The number of zeros is 1, 2, 3, 4, 5. The number of turning points, 1, 2, 3, 4.
Hi, Staff. Just to let you know, there's some donuts and coffee up in the foyer. Please help yourself.
Okay, if you're at school right now, there are donuts and coffee in the foyer for you. All right, end behavior. As x approaches negative infinity, the function is going down. So the y values approach negative infinity. As x approaches positive infinity, as we move to the right, the function is going up to positive infinity. Okay, so here are the things that we want to summarize here. When your function is an odd degree, so when it's to the first, to the third, to the fifth, notice that the end behaviors are different. The end behavior is different. It's either going down and then up, or it's going up and then down. Okay, so in this case, degree is 5, that's down and up. When the degree is 3, this one was down and up. Now it can change. It doesn't have to stay that way. It could be up and down. But that's what's going to happen when it's odd degree. When it's an even nth degree, squared to the 4th, and behavior is always going to be the same. So that means they're both going to be up, or they could both be down. If it was a negative x squared, then it would be both end behaviors for a parabola would be pointing downward like that. The direction of the end behavior is determined by the lead term, by the lead coefficient, okay, by the sign of the lead coefficient. Okay, so that's going to determine when things are going up or things are going down. The maximum number of turning points is going to be n minus 1. N is the degree, so you'll have one less turning point. Now that's at the most. For example, for the 5th degree, it doesn't mean you're going to have 4 turning points. You may not, okay? But the most you can have is 4. And then here's the real key. The maximum number of real zeros for an nth degree polynomial function is n. If it's a 5th degree, the most real zeros you can have is 5. If it's a 4th degree, the most real zeros you can have is 4. So let's go ahead and flip it over. Let's look at a couple examples here. Having this information can help us in terms of graphing. Okay, so number 6. Find the zeros of each polynomial function and then sketch the graph. This is where factoring can be really nice. Okay? First of all, the lead term, we want to focus on that. We want to pay attention. Lead term is x squared. Okay? Positive 1x squared. The factors, let's write this in factored form. So f of x equals, what multiplies to 8 and adds to negative 6? Multiplies to 8, adds to negative 6. That's going to be negative 4 and negative 2. So we have x minus 4 and then times x minus 2. So there's your function. The reason why we like this is that if we wanted to solve, if we wanted to find the zeros, remember what you do is you set each factor equal to 0. So x minus 4 is 0 or x minus 2 is 0. And when you solve it, you would get x equals 4 and you would get x equals 2. So those are your zeros right there. When we graph this, we just want to have an idea of what it looks like. We don't need a perfect graph, but we do know that the zeros are going to be at positive 2 and positive 4. So I'm going to put points there. Now let's see, what else do we know about this? We know that the lead term is x squared. So think about this. If we want to find out, okay, what happens way off to the left here? Let's say you want to plug in a negative value. And then is the function going up or is the function going down? Well, in this case, we know. The lead term is going to dominate your whole function. Okay, so it doesn't matter if you have subtraction or if you have addition later on. We focus on the lead term. That determines your end behavior. If I plug a negative into x squared, I get a positive, no matter what. So I know that the end behavior, the function is going to go like this. Now, each of these zeros, it's not a double zero. It's not something squared. Okay, so I know we're going to go down. We're going to go through the 2. At some point, we're going to turn. We're going to come back. We're going to come through the 4 for that 0. Now, as you start plugging in positive values, way out here, you're going to square. And when I square a positive, I get a positive. So the function will look something like that. Now, that's not perfect, but that's the general shape of that. Now, if you wanted, you could find the y-intercept. You could plug a 0 in for the x. And if you did f of 0, and you do, I'm going to plug it into the factored form. that would be negative 4 times negative 2, which is 8. So 0, 8 is going to be your y-intercept right there. Okay, you don't necessarily need that, but if you wanted that information, you could find it. All right, let's take a look at number 7. What does this tell us? It's in a factored form, which is nice. So we've already got the factors. So the factors are x plus 4 and x minus 2. The zeros, if you take x plus 4, if that's the factor, the 0 is negative 4. And then here, the 0 would be positive 2. If the factor is x minus 2, the 0, if you solve it, would be positive 2. Now notice that this one is a double 0. This is a double 0. So I'll show you what happens here in a second with that. Let's go ahead and draw our coordinate plane. I'm going to plot negative 4 on the x-axis. I'm going to plot positive 2 on the y-axis. The lead term, this will be x. Now, in this part, if I square this out, this would be an x squared. So my lead term would be x times x squared if I multiply it all out, which is x to the third. Now, that's an odd degree function. That's a third degree function. So the end behavior is either going to be, excuse me, up and down, or it's going to be down and up. Because this is a positive 1x to the third, think about this. Excuse me. If I plug in negative values for x as I move left, if I cube a negative, okay, negative times a negative times a negative is still a negative. So from the 0, I'm going to be going down because I'm going to be going down to negative infinity. Okay, so what happens? So we're going to start from the left. We're going to rise. We're going to hit the 0 and come through. At some point, we'll hit the axis and we'll come down. Now, what happens when I get to the 2? That's a double 0. That means it's going to bounce. So I'm not going to go through. I'm going to bounce off the 2, and then I'm going to keep going right there. So the function's going to look something like this. Now let's see. That's what I think is going to happen. Let me go to y equals and check that out. X to, whoops, parentheses x plus 4, and then parentheses x minus 2 raised to the third. Zoom 6. Now I may not see everything here. I definitely don't. So, wait a minute. Y equals, oh, x minus 2 squared. Excuse me. Okay, there it is. So it goes up, hits a maximum, local maximum, comes back down, bounces off the x-axis, and then it finishes up here. And it should finish. The end behavior should be like this, because if I plug a positive number into x to the third, I get a positive still. Okay, and we're going to stop there from part 2, and then we'll finish up in part 3.